I'll talk about my classifier, which is basically based on the Naïve Bayes classification for text. So here you can see this is my main function. There's only one file here for this program. So I basically have several local variables to store the raw data imported from the outside file. And here are two local variables also for, say, the later calculated priorities. So they're important. And here is a main function. I just gonna run it to see the result of the testing to show like how my model working. Yeah, here you can see I basically test the three questions inside the write-ups. So first test result provides an overall classification accuracy, which is near 1. It's pretty cool. And then the second one, I took a sample which is size of 20 inside from the test data set, and I compare their actual label and also predicted labels. They're 100% match with each other for the sample. And then the last one is I output intermediate results, which is for the several terms complete class probabilities, and then you can check them later by yourself. So now I'm gonna talk more about my code details. So inside the main function, I basically doing call all the training function and also the testing function here. I read the data here and calculate prior probability for each class and also calculate conditional probability for each term. So here the training part just finished, and then below those part, there are all testing parts, as you see. So then I'm gonna talk about the detailed functions. So for the training part, I use this function to calculate the prior probability for each class. You can see I iterate through the training data to record down the intermediate value, which is the number of the documents with the specific label. And also those numbers will be divided later by the total number of the documents or the instance inside the training data set to give out the exact prior probability for each corresponding label. And then I use this function to calculate the class probability for each specific term. So basically, I follow the formula in the slides. So I iterate through the train matrix data file, those data from that file. So to record down those two very important numbers. One is the total number of the specific term that occurred in specific labeled documents, and the second one, the total count, is the total number of the terms that occurred inside this the same labeled documents. And then I think I do the +1 to the numerator, and I also do the +b to the denominator to achieve the Laplace smoothing. And then finally, I do the final division here in this part to calculate the exact conditional probability given each label for each specific term and just store them. And then you can use this utility function to get specific conditional probability. And also here comes to the testing part. You can see I use this function to do the prediction for each new instance inside the test data set. So instead of using the original one method inside the slides, I use an alternative way that's posted on D2L to sum up the log of several components and then compare them to get the maximum relative probability, and also take the corresponding label for this to be considered as this test instance label. So here you can see I just do the nature log here to I iterating through the test matrix data and take all the conditional probability for the terms occur in the documents and sum it up with a log of the prior probability of the same class, and then I just sum them up and do the comparison and take the label with maximum relative probability, and then there are some functions that you can use to output the portion of the labels and also calculate the accuracy here. I hope you enjoy it.